So we have our points of concurrency in general means a point where 3 or more lines coincide, meaning where they intersect. It's a fancy way of saying that. Circumcenter, we already started that yesterday. It's where 3 perpendicular bisectors meet. But how many lines did we make yesterday to create intersection?
2.
Just 2. 2 is all you need. You can make 3 as your third line as a checking point, but you do not have to. And circumscribe simply means a circle that is on the outside of a polygon that we're going to add on to today. All right, just like what we did yesterday, let's go ahead and name our triangle. So if you were out on the part where we were making the triangle, I'm going to repeat it today as well. So let's go ahead and find the midpoint of CB, and we're simply approximating. And I was asking you guys to use your ID badge yesterday, right? Yes, a crumble cookie. Yes, use that. So we have perpendicular line at the midpoint. And I'm going to go all the way down. And also notate that they're congruent to, and I have a perpendicular line. Now, yesterday we did highlight this. Today I don't want to, but there's something else I want to emphasize. So when you guys are done making your first perpendicular bisector, give me a thumbs up. Look at you. All right. Now let's make another one at AC. Pinpoint out the midpoint of AC. Make your 2 tick marks consistently. And again, with your right angle, ID badge ideally. Here we have our perpendicular line. And extend it how much ever you want with a perpendicular sign. So here's the only thing that we are going to add on to today that I'm going to change my pen color for. Put a dot at the intersection, and let's go ahead and call that point D. And what I want you to do at this point is, I want you to connect the circumcenter D to all of your endpoints of your triangle. And yes, I'm going to use my straight edge. You can freehand draw, doesn't matter. So for today, let's highlight those 3 segments from the circumcenter to the endpoint with any color you want. And if I tell you I can actually make a circle around this, and we're just going to, pretend like we have a perfect compass, make a circle around. And yes, it's got to hit all the vertices. Mine might not look like a circle, probably more like an oval, and that's okay. Is that more like a circle to you guys?
Yeah.
Oh, not bad. Secret artist over here. And I want to share something that is unique that you guys already know of a circle. In a circle, if I make many radii, what do I know about every single one of that radius all the way through? That they're always congruent no matter what. The radius in one circle will always be congruent as long as you start from the center to the edge. And in this case, the AD, BD, and CD is considered the radius. And our given fact is the following. Let's write this on the side. They must be congruent because 3 perpendicular bisectors create 3 congruent segments from the circumcenter.
Because it's basically the center of the triangle.
Center of the triangle, specifically center of the circle in the end. Because it is a circumcenter. And I know these are brand new to you guys, so you have to memorize these. And we'll do one more like this on the back, but let's apply the rule on the bottom when you guys are done. That circle looks good. And I'm talking to Macy.
Yay!
That actually looks good. That looks good too. Was that free hand drawn? What? As a center, and you used it like the, what's that called? Compass? Emma, let me see yours.
It's not that great. It's very
It's better than mine, I'll just say. The best way to disguise your mistake is when you make a little sketch and make multiple lines. You can't tell. Right?
In one way or another.
So when you're not looking good, just start doing this. And they'll go, oh, you look good today. All right, let's apply this. So if I have an acute triangle, obviously what I gave you on the top is an acute triangle. Would you agree the circumcenter, it was in the inside? So I want you to put a dot whatever inside you want. And this you must know very, very well. So circumcenter is in the inside if it's an acute triangle. So if it's an acute, it's in the inside. What can we predict if it's an obtuse?
Outside.
It's going to be outside. And wherever outside, put it wherever you want. Doesn't matter. Now, before we do the right angle, let's go straight to the equilateral. Isn't equilateral as specific as possible in a triangle?
Yes.
So that one should lie where? Exactly in the middle. It is in the inside, not only because it's an acute triangle, it's also an equilateral, so it's at the center specifically. So if the acute is inside, obtuse is outside, what can we predict about right angle? It's on the hypotenuse. And it's specifically on the right, or not right, midpoint of the hypotenuse. And we'll do an example of this one that's mathematically done, but not the others. Those are impossible. So let's go on to example number 1. All right, Bobby, let's read example number 1.
What is the circumcenter of triangle OPQ? OS equals 10, QI equals 12, and QQ equals 22. Find OP, RP, OR, PP, and RT.
All right, so the main thing is the fact that we have a circumcenter. So what I can do is the following. I can go ahead and say these two have a common tick mark. These two have a common tick mark and a common tick mark. And then lastly, our radius of that circumcenter, if you want to make your little circle, oh God. I guess that's doable. And if you would make your center to the vertex, which becomes the radius, or the radii of that circle, and make 4 tick marks to be consistent to say that they are congruent to. And let's put in the known measure. It says OS is 10. Then what do I know about SP? I have a common tick mark. SP should also be 10. And then it says QR. QR is 12. So can I then say the other two are also 12 since it's a radius?
Yes.
Yep. And then I have PQ. If P all the way to Q is 22, what can I say about half of those each?
They're 11.
They're 11s. And then we're looking for OP. So let's write out. OP is equal to how many then?
20.
20. What about RP? 12. What about OR? Also 12. And then we have TP. TP is 11.
Yeah.
Okay. And the only one that's going to involve work is going to be RT. Oh, that's not R.
Oh.
RT. So
The,
let's take out a different color real quick. So RT has to do with this triangle right here specifically. Bless you. Don't we have a right triangle there?
Yes.
Can I use Pythagorean theorem?
Yes.
Yes, I can. So I can write out a squared plus b squared is c squared. My a, I'm going to call that the unknown. Bless you. Then we have b squared is a 121. Is everyone okay with that? Yes? C squared is how many? 144. And then when I subtract 121 on both sides, and yes, do the work on the side on your own in your head. So 144 minus 121 is 20 how many? 23. And even if I square root this, we're not going to be able to compute this because 23 is, first of all, prime number. And it's going to be some ugly decimal. Let's leave it as it is. And that is our final answer. So as long as I tell you something is a circumcenter, you may use all the facts about it. So on the back. Everyone good with this? Okay, on the back. Let's find the circumcenter of a right triangle. Okay, Atkins, let's read number 3.
Find the circumcenter of RSO with vertices RSO.
RSO and the points given. All right, let's go ahead and plot it. Here's my R. And then my S is 0, 12. And then we have O is 4, 0. It's very tall. It's the opposite of me. No? You guys are just being nice today.
Well, no one said that.
Oh.
Right.
So here we have a right angle. And so according to what we said previously, the circumcenter has to be the midpoint of the hypotenuse. So let's write out our circumcenter. All we care about is the midpoint of the hypotenuse. So let's highlight the hypotenuse only. And can we pinpoint out the midpoint given that we have it on a graph?
Yes.
So really in the end, if I really went down 12 over 4, can I half those two and say down 6 over 2? So when I go down 6 over 2, that is my midpoint. So our circumcenter is 2, 6. So instead of overthinking it, understanding the fact it's going to help you to minimize this problem. So if we really went down 12 over 4, right? So midpoint is half of each. So down 6 over 2 instead. 12 divided by 2 and 4 divided by 2. All right. So let's see if you guys were paying attention yesterday on our notes. Blank is the point where 3 perpendicular bisectors intersect. What was it?
That is
Circumcenter.
I would have gotten it.
And then it's going to be another circumcenter because I didn't really go on to the next topic. It is equidistant, same length from the vertex of the triangle. So let's kind of go back to what we had. This point, is it equidistant to all the vertices given? Yes, it is. It's still circumcenter. So again, understanding the fact about the circumcenter will help you definitely. Would this be a helpful phrase for you guys to kind of study? Yep. Maybe. Maybe everything's important. Macy.
Is there a circumcenter of a rectangle?
Is there a circumcenter of a rectangle? There's a circumscribed of a rectangle.
Would it just be the middle of the rectangle?
Yeah, it will be because it's all 90 degrees.
Right.
So really the answer is yes, but we're not going to deal with it. All right? All right. The next piece, let's write out our definition. In center of a triangle, we already dealt with yesterday, but it is a common point of 3 angle bisectors. How many bisectors are we going to make, though?
2.
Just 2. Make a third one if you want to. So circumscribed was a circle on the outside. So inscribed must be the circle on the inside. Doesn't it sound like it? In, circum, in, no, kind of. All right, let's name this just like yesterday. ABC. And we are only going to approximate. Does not have to be perfect. So I'm going to go to angle C and say maybe ish over here might make this angle bisector. Maybe that's not perfect. And it's okay. And let's notate that these two are congruent too. Does it matter if you bisect the A or the B? No. So I'm going to go ahead and bisect B. So I have angle bisector right here. Ooh, that was dramatic. And let's swing into tick mark. And let's put a center or at the intersection. And let's call that point D again. All right. So an interesting fact about this. So if you're using different colors, I want you to try to pick a different color on the next piece. So this is nothing new from yesterday. So we're going to add on to this. So what I want you to do is go to point D and drop it down perpendicular to the opposite side. And then I want you to go to point D, make it perpendicular to AB. And sometimes it could be the actual ray that you made. And maybe the other times, maybe it's a little off, just like mine. And I'm going to make it perpendicular to the other side. And again, since I approximate it, my drawing may not be perfect.
It's not perfect.
You know, I like to think that I'm perfect, but that's not the reality. Let's rename this EFG. So again, if your point happened to be the exact same location as a bisector, it's okay. It happens. So here's what I want. Just like on the circumcenter, how we made a little circle, we are going to make a circle as if that is my radius. That's going to touch F, E, and G around. So that's our challenge to ourselves. That's not bad.
That is a great circle.
I'm going to be an artist. Would you guys buy my art?
Maybe.
Oh, someone said yes? Okay. I'll spend more time than 2 seconds. How about that?
That sounds good.
No.
All right, no.
We want the 2-second art. That looks good.
Does it look more original? Okay.
Yeah.
Let's go ahead and highlight those radius or radii.
Or like the 30-second monkey. Yeah.
And we know those are congruent too. So basically, circumcenter is going to create the circle on the outside. Incenter is going to circle or make the circle in the inside. And if you think about it, incenter, inside. No? Kind of? All right, so here's our conclusion. So we know FD, ED, and GD have to be congruent because 3 angle bisectors will create 3 congruent segments from the incenter D to the perpendicular side. I should really say to the center or center D to the point on the perpendicular side. But I have the picture. Let me see your circle. I approve. That's good. And then Campbell, that looks good. Hannah, that looks good. You guys are good at circles. All right. Should I read this one more time? No, you're good? Okay. And we have 3 more questions on the bottom and we're done. All right, give me a thumbs up when you're ready for the questions on the bottom. About half of us. On my desk. On my desk. Thank you. Okay, going up. Going up. All right. So on number 5, Josh, let's read.
MP and LP are angle bisectors of triangle LMN. Find the distance from P to MN and the measure of angle PMN.
So we have an angle bisector. So from here, we know this triangle has a distance of 5. And if y'all remember yesterday, the distance from the point to the opposite side is always perpendicular. Let's go ahead and make our perpendicular sign. And it says to find the distance from P to MN. So P to MN. So here's P to MN is right here. Again, the distance is always perpendicular. If you want to make a circle, go for it. If you want to look at the circle above, do that as well. So what do I know about the distance from the center to the side that is perpendicular in an incenter at all times? They are all the same. Boom. And then it says measurement of angle PMN. So PMN is right here. So let's look at the triangle overall. Because we have an angle bisector, can I repeat this angle 15 right above?
Yes.
Yep. And since I have 20 and 30, 20 and 30 gives how many?
120.
So 180 minus, how many is that, 50?
120. Oh, 130.
130? So we know this full angle M is 130. So how many is half of that? 65. Again, this you can only get if you understand the facts about the end center.
Wait, so since this is an obtuse triangle, wouldn't the end center be outside?
That's for the circumcenter.
That the circumcenter.
Only circumcenter. All right. For example, number 6. So we have blank is a point where 3 angle bisectors intersect. We know we just talked about end center. A point that is equidistant, same length, from the side of a triangle. So equidistant from a side of the triangle is also end center. And I think there was a way, yeah. I think my students shared previous years how to remember this. Let me think. It's not going to be very helpful. So I'm going to stop right here. Do we have a back?
No.
No back? Perfect.